All atoms have a nucleus that contains protons and neutrons. And then around the nucleus, we have orbits or shells that contain electrons that constantly move. And these electrons are not placed randomly. They follow some specific rules. The way electrons are arranged in an atom is what we refer to as electronic configuration. So electronic configuration basically refers to the arrangement of electrons in the orbits or shells of an atom. So that's what we'll be considering in this particular lesson. So every atom has a nucleus that contains protons and neutrons. And then we have shells around or orbits around the nucleus. These orbits are known as energy levels. The first energy level or shell around the nucleus is designated with alphabet K. So that is the K shell. It is the lowest possible energy level. The second energy level is the L shell. Then the third is the M shell, and then we have the N shell. There are other shells out there, but for the first 20 elements, this is how far it goes. So these are the 4 energy levels the first 10 elements on the periodic table have. Now, to find it easy to remember these shells, then try to remember keep loving me now. If you know keep loving me now, then I'm sure it will be easy for you to remember the energy levels, the K shell, the L shell, the M, and then the N. Each of these energy levels have some specific number of electrons that they can actually hold. And the formula for determining the number of electrons that an energy level can hold is 2n exponent 2, where the n stands for the energy level. So if the energy level is the first energy level, the n will be 1. If it is the second energy level, the n will be 2. So our first energy level is K, which is the lowest energy level. So for that, we'll have 2 times 1 exponent 2, because n is 1, or K is shell number 1. So that means 2 times 1 exponent 2 will give us 2. So to put it simple, it means the first energy shell, which is the K shell, can have a maximum of 2 electrons, while the second shell, which is the L shell, which is shell number 2, will give us 2 times 2 exponent 2. 2 squared is 4. 4 times 2 is 8. So the second shell, which is the K shell, can have a maximum number of what? 8 electrons. The third shell is the M shell. So using the same formula, it can have a maximum of 18 electrons. And then the third can have a maximum of 32 electrons. So these are the maximum number of electrons these shells or energy levels can take. But for the first 20 elements on the periodic table, this is how the electrons are spread out. That is from hydrogen all the way to calcium. It's read as 2882. 2882. So for the first 20 elements, the first shell can take 2 electrons, the second can take 2, the second can take 8, the third can also take 8, and the fourth can take a maximum of 2 for the first 20 elements. You might be wondering, for the formula that we used, the third shell can take 18, but why are we saying that for the first 20 elements, the third shell can take a maximum of 8? Well, that is a little bit higher level of chemistry, so do not stress yourself too much about that. For the focus of this lesson, our focus is from only the first 20 elements, and all you need to know is for the first 20 elements, the maximum number of electrons the third shell can take is 8. As you proceed in your understanding of chemistry, when we start talking about the S, the D, the F suborbitals, then you get to understand these things into detail. With all of this cleared out, let's try to write some electronic configuration, picking some specific examples. For the first one, we'll be considering sodium. Sodium has an atomic number of 11. Since we say sodium has an atomic number of 11, it means that the number of protons sodium has is 11. And this sodium atom is neutral, meaning it has 11 electrons. So using the rules, the electronic configuration of this sodium will be 281. 281. 2 plus 8 is 10. 10 plus 1 is 11. So 281, meaning the first shell has 2 electrons, second has 8, the third has only 1. Let's draw this out and see how it will look like. So start up, we have the nucleus of the sodium atom. So inside we have protons and neutrons. The first shell, which is the K shell, has 2 electrons, 1, 2. Then the second shell, which is the L shell, has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in total. And then the third shell has only 1 electron. So this is how the electronic configuration of sodium is written, and it is how it is drawn. Well, let's pick our next example. That will be a much bigger element, that is chlorine. Chlorine has an atomic number of 17, meaning the number of protons chlorine has is 17. And if chlorine is a neutral atom in this case, it means the number of electrons is also 17. So how would these electrons spread out in the shells of the atom of chlorine? It will be written as 287. And if you add 2, 8, and 7, you would get 17. Let's try to write this out or draw this out in terms of diagram. So chlorine has a central nucleus that has protons and neutrons in it. The first shell, which is the K shell, has 2 electrons. And the second shell, which is the L shell, has 8 electrons. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in total. While the third shell, which is the M shell, has 7 electrons. We have 1, 2, 3, 4, 5, 6, 7 electrons in total. So if you count the electrons, which are represented using the red dots, you realize that there are 17 in total. So this is how the electronic configuration of the first 20 elements are written. Although if only illustrated using only sodium and chlorine, the steps remain the same, and understanding this will help you write all other electronic configuration of the remaining elements. With this understanding cleared, our next lesson will be discussing the formation of cations. So subscribe to the channel so that you wouldn't miss out on that lesson. See you in our next lesson.